This is part 2 of the Math 6 review packet for Chapter 1. We're going to start right into it. Our next essential question says, without dividing, how can you tell when a number is divisible by another number? So this is kind of going to go back to our divisibility rules. We glued one of those into our notebooks. So hopefully you guys are familiar with those now. And our directions say list the factor pairs of the number. So I have for number 15, the number 21. So here I'm going to make a T-chart. You could also do the listing or that rainbow method. But what I'm trying to do is find two numbers when I multiply them together equaling 21. So again, like I always say, we start with the factor of 1. Every number has a factor of 1, and it's always 1 and itself. 1 times 21 is 21. Now I have to think of another factor pair, or if there is another factor pair. And in this case, there is 3 times 7 is 21. So right there, I have two sets of factor pairs. And I'm done for number 21, or the number 21. So number 16 has my number 45. Again, I'm going to draw a T-chart. You could make a list, do that rainbow method, but make sure you match up your factor pairs. Don't just list a bunch of numbers out. You have to tell me what two numbers together, when they're multiplied, equal the given number. So for 45, I'm going to start again with 1 and 45. So 1 times 45 is, again, 45. Then I'm going to think about what other number could divide into 45. 3 could go into 45. It would be 3 times 15. And then lastly, since 45 ends in the number 5, I know that 5 can go into 45 evenly. In this case, it's 5 and 9. So 45, the number 45 has 3 factor pairs. 17 and 18, the directions say write the prime factorization. Prime factorization, this is the important part, of the number. Now when we see that phrase prime factorization, hopefully you guys instantly think of factor trees. We've been talking about this a lot. So we're going to look at 51 and try and think of two numbers. We're going to break this number down, if possible. What two numbers, when I multiply it together, equal 51? So again, I'm going back to that factor pair idea. And in this case, 3 and 17. When we multiply those two numbers together, we get the number 51. Now 3 is a prime number, so I circle that. And 17 is also a prime number. So since I have no other numbers I have to break down, they're both prime, I found the prime factorization. Now when I write the prime factorization for 51, I have to remember to write these numbers from least to greatest. So I would write 3 times 17. Because prime factorization is multiplication. We have to write those prime numbers with multiplication signs. Number 18 is 120. This factor tree can have a couple different options. I'm going to start with 2 and 60. I know 120 is even, so I know 2 can go into it. You could start with 12 and 10, 3 and 40, 4 and 30. A couple different options there, but I'm going to start with this one. Then 60 is not a prime number. It is a composite. So I'm going to break this number down. 3 and 20. 3 is prime, so I will circle that. 20 is, again, composite. I'm going to break 20 down to 4 and 5. 5 is composite. 5 is prime. 4 is composite. So this will be 2 and 2. So then for the prime factorization of 120, again, I have to write this from least to greatest, so I have 1, 2, 3, 3 2's. So I'd write 2 times 2 times 2 times 3 times 5. That's one option. Or if you like to write it as a power, if you're comfortable with that, we could have 2 to the third power, or 2 cubed, times 3 times 5. Either one is correct. Now my next section says, how can you find the greatest common factor, and this should say of two numbers. So there's a couple different ways we could find the greatest common factor. We could do the listing method. We could also do prime factorization and look at the prime factorization of both numbers. So I'm actually going to do one of both so you can see that. Some of you prefer to do the listing method. Others prefer to do the factor trees. So I want to do one of each. So for number 19, I'm going to do factor trees. I'm going to take 18 and I'm going to factor this down. 9 and 2. 2 is prime. 9 would be 3 and 3. And then I'm also going to make a factor tree for 78, 2, and 39. 39 is 13 and 3. So then I'm going to write their prime factorizations out from least to greatest, one on top of the other. 18 is 2 times 3 times 3. 78 is 2 times 3 times 13. And I'm going to see what they have in common. They have 1, 2 in common and 1, 3 in common. So what I do here now is I multiply those two numbers that they have in common. Since there is more than one number in common, I multiply these. So 2 times 3, which is 6. So I would write my sentence, the GCF of 18 and 78 is 6. And I would box that answer there. Now, some of you might have used the listing method. If you used that method, hopefully you still got the number 6. That is the correct answer there. For number 20, I'm trying to find the greatest common factor of 9 and 42. Here I'm actually going to do the listing method. So I have one of each. For 9, I'm going to do the rainbow for us. 1 and 9. 1 times 9 is 9, and then the only other left is 3. So I'm just going to put that there. Since 3 times 3 is 9, I don't write 2 3s. Since 3 and 3 are the same number, it's just one factor. And then for 42, again, 1 and 42, it's always 1 in itself, is 1. I have 2 and 21. Those match up. I have 3 and 14. And then I also have 6 and 7. So I look at my lists and I see what they have in common. They have a 1 in common, but they also have a 3 in common. So 3 here would be my greatest common factor. So I would write my sentence, the GCF, the greatest common factor of 9 and 42 is 3. And I would box that in or circle that. Then I'm going to move on to 21 and 22. It says, how can you find the least common multiple of two numbers? And my directions say, find the LCM. So for 21, I have 9 and 12. You can do the listing method here, or you could also do factor trees again. So I'm going to do one of each. For 21, for 9 and 12, I'm going to do the listing method. So I'm going to list multiples of 9 and list multiples of 12, trying to find the least common multiple of both of these numbers. So 9 times 1 would be 9, 9 times 2, 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45. I'm going to stop there. I'm going to do some multiples of 12. 12, 24, 36, 48. And I see that they do have something in common. It would be the number 36 here. So that would be my least common multiple. That's the first multiple 9 and 12 have in common. So it will be the smallest. So I would write, again, my sentence just like GCF, except the LCM of 9 and 12 is 36. Be very careful. When we're talking about least common multiple, we have to make sure that that LCM is greater than or equal to our numbers that we start with. It can't be smaller than our numbers we start with. Those would be factors. Here we're looking for multiples. Remember, the word multiple has the word multiply in it. Now for 22, there are 3 numbers we're trying to find the LCM of. I'm going to cross off that 3. Hopefully you guys did that as well. And I'm going to use 16 and 20 here. I'm going to do factor tree method. Now this one can be a little bit more confusing, but I do want to show it. Some people prefer this method. And it doesn't tell me which method to use, so I can choose my own. So I'm going to do factor trees of 16, or a factor tree of 16. 4, 4, 2, 2, and 2. So I factored 16 down. I'm going to factor 20 down using a factor tree. 2 and 10, 5 and 2. So what I'm going to do now is list their prime factorization, 16 is 2 times 2 times 2 times 2. 20 is 2 times 2 times 5. Now here, I need to see what they have in common. So this, again, right now looks like the greatest common factor method, because it is. We're taking that method, taking it one step further to find the LCM. So for 16 and 20, they have 1 2 in common, and they have another 2 in common. So remember, I'm going to make my common list down here. And they have a 2 times 2 in common. Now I want my remaining list, the ones that aren't circled. So I have a 2, and a 5. So for remaining, I have 2 times 2 times 5. To find the LCM here, I take my common list and I multiply that by my remaining list. So I do 2 times 2 times 2 times 2 times 5. In this case, that is 80. So I'm going to write my sentence, the LCM of 16 and 20 is 80. And that would be my final answer. Again, if you use the listing method, you should still get the same answer. 23 and 24 are adding and subtracting fractions. Write the answer in simplest form. So for 23, I have 7/8 plus 3/10. I'm going to find the LCD, the least common denominator, of my two denominators here, 8 and 10. So I'm going to list some multiples of 8. Right down here. So I have 8, 16, 24, 32, 40. For 10, I have 10, 20, 30, and 40. So my LCD would be the LCM of my two denominators, the least common multiple of my two denominators. In this case, it is 40. So I'm going to rewrite both my fractions with the denominator of 40. Now the trick is, I changed my denominator. Now I need to change my numerator as well. So how did I get from 8 to 40? What did I have to multiply 8 by? In this case, I had to multiply it by 5. Whatever I do to my denominator, I have to do to the numerator. So 5 times 7 is 35. To get from 10 to 40, I multiplied by 4. That is my fourth multiple of 10 40th, so I multiplied it by 4. So I have to again do that to the numerator. 4 times 3 is 12. So now I've got the common denominator. I can add both of my numerators. So 35 plus 12 is 47 over 40. Now that is called an improper fraction, so we need to change that. How many 40s go into 47? 1 whole, and then I have 7 left over, 7 40ths. And that is written in simplest form. Now I'm going to stop this video. I'm going to make one last video to do the remaining problems. So continue grading. Hopefully you're doing okay. If you need to rewatch anything, please rewatch.